Hey y'all, welcome back to the Hack Shack. Today we've got another box from the folks at Hackerboxes. This is Hackerbox 101, and the name is Archives. Let's get this on the bench and see what we have inside here. This is the Light Reactive Firefly Robot Kit. This is the Atmega 328P Arduino Nano with the Type-C USB connector. This is the DS1307 real-time clock module. This container looks to have some red LEDs, some ICs, and some IC sockets. This bag looks to have some headers, resistors, a bunch of switches, and a bunch of white and black switch button covers. And also some coin cell batteries. This is the exclusive Kenbak-1 reproduction front panel PCB. And this is the exclusive Kenbak-1 reproduction main board PCB. And here we have 3 archive themed hacker stickers. Nice throwbacks there with Mondo 2000 and the Byte sticker. And last but not least, our Hackerbox 101 collectible reference card with this trippy AI art looking stuff right there. And on the back, we've got references for our real-time clock and the 2 converters we'll be using. And I also really dig the artwork this month. Pretty cool. Before we move on, I'd like to take a moment to thank today's sponsor, PCBWay. Are you any good with KiCad? I'm not. The only thing I've really done so far is this basic single-sided PCB that I etched at home. If you do have KiCad skills, you should enter the KiCad Open Source Design Contest hosted by PCBWay. Projects can be submitted through June 2nd, 2024, and results will be announced on July 16th. There are 10 great project awards, and everyone gets a participation award, which consists of a Raspberry Pi Pico and PCBWay and KiCad bag. So if you've got the skills, don't delay and enter today. Good luck. Check the link in the description for rules and more information. Just like they always do, the folks from Hackerboxes have included a great set of instructions here available on Instructables. I have a link to that in the description. Even if you don't have the Hackerbox, you might find it pretty handy. As you've probably figured out by now, the main focus of this Hackerbox is making a replica of the Kenbak-1 computer. I was super surprised to see this little note here that one of my videos had inspired the thought of doing a Kenbak-1 related Hackerbox. So this video stays on topic. I don't want to try to dwell on too much stuff here. I've got a video I've done on kind of the history and the making of my first micro Kenbak kit. I've got a little video showing the nano Kenbak that I also got from Add Water and Stir. So I'll have links to those, and there are tons of other great resources. There's some links in the Instructable. I'll also put them in the description. It's just a neat system, so go out there and check it out. It's got some neat history to it, and I'll just leave it at that, and we'll get on with building the kit. Okay, the first thing that the Instructable instructs us to do is to connect up our Nano with a USB-C cable, which is not included. You'll need to get your own. And we should see the power light come on, and it actually should start blinking the LED here. And it does that without us loading anything because it has the blink sketch already loaded on it from default. So that's our first good health check there. Next, we want to set things up correctly within the Arduino IDE that you've hopefully installed. So you want to connect the Nano up to a USB port, launch Arduino, and then inside Arduino, you want to select Tools Board, Arduino Nano, and then go to Tools Processor, Atmega 328P. Also then go to Tools Port and pick the COM port that showed up when you plugged in your Nano. Next, the Instructable tells us to go to File, Examples, Basic, Blink, and that's going to load up the blink sketch, which should be actually the same code that's running on it already. But we'll load that, we'll push it to it, and let's compare and see if it is actually the same. Now, I've tried to line up the previous clip with the one we just did, and as no surprise, you can see that even though I didn't quite get them lined up exactly, that they're pretty much blinking at the same rate. So there we go. Next, we were instructed to go in here and modify the code and change those delay statements that have delay 1000 to delay 100. And we're going to push that code to it. We'll see if that makes it blink any faster. And of course, you look here and you can see that it's blinking much faster And if this is your first time really messing with any code, it's a neat way to see how you can change code and see the results reflected in a real piece of hardware in the real world. Next, the Instructable tells us to start assembly of the white front panel PCB. The first thing we're going to do there is cut the male 2x40 SMD header into 4 sections, having 2x10 pins each. Next, we're going to solder these to the backside of the white PCB. This one pin got a little wonky, so I used some pliers to straighten it out a bit. Next, we mount our 15 momentary buttons to the front side of the PCB. Next, I gathered all the red LEDs out of the container and got ready to follow along on the next step here. And that's where we're going to mount the 12 LEDs to the front side of the PCB. And just like it says here, the short leg is negative, and that's going to be facing down as you have it oriented like this. On these, I kind of ran through on one side and just put a little drop of solder on each one, and then I came back and applied pressure while heating up that solder that's already there to make sure that the LED was flat against the surface of the PCB. And then I come back around and solder the other side of all the LEDs. Then just trimming out these excess leads. Here I'm just going through and soldering all the momentary buttons in place. I notice I'm a little bit out of order compared to the Instructable, but here's where I'm trimming off the pins of the read button. Just follow the directions here so to minimize the chance of it shorting out with the RTC battery. After all that soldering on this pretty white PCB, I used a little IPA and a toothbrush to try to clean things up a bit. Next, I put the black and white button caps onto the buttons based on a reference picture of the real Kenbak-1. Starting to look like something, eh? Now it's time to move on to the main board assembly. And I'm not great with seeing these color bands on resistors, so I got my trusty meter out here. And I identified what I thought were the 10K and what looked to be close enough to be the 220 ohm resistors. Next, we're stuffing 15 of those 10K resistors in positions R20 through R34. Then we stuff the 12 220 ohm resistors in positions R0 through R11. As we prepare to mount our IC sockets, it's good to pay attention to where the notch is on the PCB and the notch is on the socket. And it's worth looking closely to see how this particular one has the notch pointed opposite than the other two. Next, I'm mounting the sockets here, and you'll see I'm using some blue tack replacement, not quite as good as blue tack, and that's going to come back to be a pain a little bit later on these. Next, you'll see we're jumping around a bit compared to the order of the Instructable and focusing on the pins of the real-time clock. So I found those header pins and basically used the RTC module itself to gauge the size and number of pins needed, and using my pliers to snap those apart, and then going ahead and mounting that into the board. Next, a few pins were soldered just to hold the module in place temporarily. Then it looked like it wasn't quite fitting flush, but then I noticed that it was just this crystal right here. Then I flipped it over and went ahead and soldered the bottom pins, and then the rest of the top pins. Next was just a ton of soldering on the back side of the board. That included soldering in the resistors, clipping those excess leads, and soldering in those sockets. And here's that pain I mentioned earlier about the putty. Some of it had gotten down into the actual pinholes in those sockets and all around, so I had to dig it out, and I ended up using a pick as well a little bit later to fully clear out the pinholes. My next bright idea that I had was to socket the Arduino Nano so that if something ever happened to it, I could more easily swap it out since I really like this kit. However, I quickly realized that this would be much too thick and wouldn't let the two cards sandwich together properly. So then, of course, I had to undo all that, which was a bit of flux, a lot of solder braid, some solder sucker, and then it has some clippers just to clip things out, but finally got it out and cleaned back up. And then I proceeded to just put the Arduino in the way I should have to begin with. Next, we're going to move forward with the Instructable and mount our 4x10 female headers here on the board. I want you to look here real quick at what the Instructable says to do, and it, I think, is better than what I did. It tells you to actually put the female headers onto the male headers of the front panel PCB, then basically place your main board onto that, and it'll kind of hold everything in place perfectly while you solder them in. You'll see that I did not do that, but it still ended up working out in the end. A little cleanup after that soldering. And here we're adding the coin cell to the real-time clock module. And here's the extra cleaning of the sockets to clear them out that I mentioned earlier that included some action with the pick here. After things were cleaned out, the actual ICs were installed in their sockets. Then it was time to join the two boards together, making sure J1 went to J1. At this point, it needed to be plugged back in to move forward with the next steps. And those next steps were to grab a Kenbak hardware test sketch from the Instructable and then push that to the Arduino, open our serial monitor, set it to 9600. Also observe when the thing's powered up, we should see the LED scroll left to right 3 times, and this gives us a chance to make sure every LED is working. But then it also will verify the button presses in the serial monitor. As we press each button, we should see that register in the serial monitor. Next, the Instructable advises us to go get the Kenbakuino project files from GitHub. So I head over to GitHub and just download that whole thing as a zip. Then I run that file, and it wants to put it in that folder. So then I get all the other files that are part of that and dump them into the folder that Arduino made. Then that is compiled and pushed to the Arduino. And as it says here, hitting any of the buttons 0 through 7 on the left side, and you'll notice that the wrong LEDs toggle. Then the Instructable goes on to tell us how to fix this, and we do that by opening up and editing the leds.cpp file within the Kenbakuino distribution. And we're going to look at line 28, and we're going to change the parameter LSB first to MSB first. And after we do that and recompile and push to the Arduino, the proper LEDs toggle when we press the buttons. Next, the instructions say hold stop and hit 0 to load a predefined counter demo. And then you hit start to do that, but you see it's way too fast here. To slow things down, the Instructable tells us to hit stop, then hold 5 and hit stop. That adds a 32 millisecond delay. And then hit start again to start the counter program again. This makes it much easier to see. Now, one thing I didn't show you earlier when I was doing my unboxing was that I took some measurements with my calipers here of the PCB because I wanted to 3D print a nice case to go with this kit. A little bird gave me an idea about some dimensions earlier, but I was just verifying, and I had to use some of this other information to kind of get a little bit of a head start. Now, as I've said before, I am very terrible at 3D modeling. I use Tinkercad and I don't even use it well, but I did know that I wanted to do a smaller scale thing at first just to make sure that my faceplate would fit in there just right. So I did that and I printed it out and I did a test here, and as you can see, it's a little bit not quite right. So then I did some tweaks, printed another one, and got a much better fit. Not perfect, but close enough for me. So then I tinkered around quite a bit in Tinkercad to try to get a case, and my goal was to kind of make one look like the original case. So that's what I kind of aimed toward making. And it took me a little bit and finally got something, and it looked like it was going to be a 28-hour or so print, which was daunting. I've never actually had a print go that long. I've printed tons of stuff, but I've never had a single piece print for that long. But I sent it to the printer, and after the allotted time, it came out, and while not perfect, very close to good. And you can see how it turned out here. I could definitely stand to tweak and tune my printer, but I was not worried about that in the slightest during this. Just wanted to hammer something out to see if I could get relatively close. And I also printed out 2 handles in silver for the sides. Here you can see where I'm putting the handles on. I used a little bit of sandpaper just to knock the edges off of those little ridges, and then they popped on there without too much trouble. If you're wondering what the hole is in the back of the case, that was for a panel mount USB-C connector. I wanted to have a little pigtail with a panel mount there so I could just connect and disconnect without having to mess with the front of the panel or anything like that. I got this one off of Amazon. I'll put a link in the description. And basically I just had to work on the port a bit. It doesn't look very pretty, but thankfully the bezel is large enough and this looks pretty good when it's all put together. That would be something that I would adjust in the CAD model before reprinting again, so I wouldn't have to have it be so ugly. I'm pretty sure I made a hole as large as what the Amazon ad said that the cutout that it needed was. And I even added about 20% just to have some wiggle room, but evidently that was not right. Here you can see where I'm getting the cable pushed in, and it sticks in there and looks pretty decent. After that, it was just a matter of feeding the cable on through and connecting it to the front panel USB port on that Nano and setting the faceplate down into the case. I'm using a little bit of that Blue Tack-like stuff to kind of hold it in place for right now, but I'm planning on maybe reprinting and having a recess for a little piece of metal for a magnet or something like that. That way it can hold in with just a light magnet but pull out without too much trouble. I'm pretty stoked with how this thing turned out. I think it looks pretty darn good. I'm excited to have this one to play with and to show others to share with them the magic of the Kenbak. Now, if you don't have a replica of the Kenbak but want to see what it was like to play around with it and program it, there is a cool web-based emulator that'll let you do all kinds of things and has some pretty neat features with it. You may want to play with that. Grab the old exercise book and see what you can make it do. I believe the Instructable also references this, but there's a nice programming reference manual for the Kenbak that you can find online. I'll have a link to it as well. You might want to check that out if you want to play with the replica or an emulator. There's also a neat lab exercise PDF out there you may find interesting. It's got some neat ways of explaining how things work and some different exercises you might want to go through. Pretty cool. So before we move on from the Kenbak stuff, finally, I want to show you how you can use the cool clock stuff within it. And to get into that, you want to hit stop +7 and then hit clear, and then you hit set, and then you want to put your time in BCD format, starting with the hours. So what I'm doing for my hours here is the first digit is going to be 1 and the second digit is 0, so that should be 10 for the hours. And I'm going to hit store and clear, and then we're going to put in our minutes. And for minutes, I'm just going to go, I'm going to have 2 for the first digit and 0 for the second digit. I'm going to hit store and start, and then I'm going to hit stop and 3 and start, and I should see the clock start now. Now it's different here when it's in the minutes mode. When that 7's blinking, only the location 6, 5, and 4 have the BCD first digit value for the minutes, and that's why that is showing the number 2 right there. So that's saying 20 per minutes, and the hour is 10, so it's 10:20. And if we speed this up a bit, we should see it switch to 10:21 in just a minute. And now we can see when it's in minute mode that we've got the value 2:1 in BCD format there, and our hour is still at first digit 1, second digit 0, so 10, so 10:21. And here you can see where our minute has ticked over to 22. So the hour's still 10 and the minutes are 22. So you can see the clock works pretty well. That's pretty fun. And this code will do all kinds of stuff. I suggest going looking at the documentation again for the Kenbakuino software, and you can see all the stuff it'll do. Like you can store your programs. You don't have to worry about losing them when you turn it off, that kind of thing. It's just really cool. It looks like we're going to have ourselves another giveaway. The nice folks at Hackerboxes have graciously offered to send a Hackerbox 101 to the lucky comment picked at random. We'll be picking the comment on May the 11th. And remember, Hackerboxes only ships to US addresses for this giveaway. So if your comment's picked, but you don't have a US shipping address that we can use, we'll need to pick someone else. Good luck. Now let's check out this Firefly robot kit. I'm going to dump all the parts out here, and it looks like everything is here that matches the parts list. I'm no good at reading these color bands on resistors, so I'm going to use the multimeter again to identify what's what and get ready to put them in the board. And then I stuff the resistors into the identified places where they go on the board. Solder the resistors in place. And then clip off the excess leads. Next, the DIP8 chip socket and LM358 chip go in. We just make sure to orient the notch on the socket to the notch on the PCB. And stick the socket in there. Then I get that socket soldered into place. Then flip it over and we put the LM358 chip in place, also making note that the half circle is oriented to match the PCB and socket. Next, we install the electrolytic capacitor, just making note to line up the positive and negative legs of the capacitor to match those on the PCB. And we solder that and clip the excess leads. Next, we put the 3 transistors in. They are 2 different types, so making sure to put the right type in each location. Then those get soldered into place, and the excess leads are also clipped off of those. Next, the blue LED and the trimmer potentiometer go in. The blue LED, just make sure that the short leg is negative or the longer one goes toward positive on the PCB. And the trimmer only goes in one way. So got those in and then soldered them in place and trimmed the leads on the LED. In goes the power switch. Next, the photoresistors go in. They don't really have an orientation. We're just told to leave a little bit extra to stick out, kind of like antennas. And we solder those in, clip the excess leads, and put some heat shrink over them to kind of act like little shields. And I heat that up with the side of the iron to shrink that down. Next, we wire in the vibration motors to spots M1 and M2 on the PCB. Next, the battery holder is wired and soldered up. What remains is just a bit of mechanical assembly. I'm going to peel the protective plastic from these legs. I'm going to bend these legs just so they kind of look like a table, like in the example pictures we've seen of the robot. Then I'm going to put an adhesive padded disc between the bottom of the PCB and the top of the leg platform. Then I'm going to do another adhesive pad between the bottom of the table platform and the back side of the battery holder. Then attaching the motors to the legs. Then just stick our coin cell battery in and we're good to go. I set this up in the kitchen on the counter and played with it for a bit with my youngest kid, and it seems to be reactive. I might have to trim these little eye shades back a little bit. But one thing I did notice, it seems on one eye it wants to go towards you and one eye goes away. I think others may have said that in the Instructable comments as well. And I found this link here, and it seems to act like maybe it should come toward the light no matter what. So I might tinker around and see if I can flip a motor or something like that and make it do that. Even still, pretty fun. If you're not subscribed to Hackerboxes and this looks like something interesting to you, they do have some in stock as of the time of recording here. So give them a look if that's something you'd be interested in. Hey, if you made it this far, thanks for watching. Hope to see you again next time. Take care. Bye-bye.